So today we are going to be discussing 12-1 trigonomic functions in right triangles. Now a lot of this stuff is going to be review from geometry, but there will also be some new things included. So we're just going to start off with an introduction and kind of a reminder of what our trig functions are. So first of all, trigonometry is the study of relationships between angles and sides of triangles. Now, typically when we are talking about an angle, we're going to use theta, but we could also use capital letters, so those usually represent angles, or depending on like the picture, we might also just use a lowercase variable. So it's really going to depend on the context, but usually we're going to see this theta here, or a capital letter. Now, we have to be able to identify the sides of a triangle in order to use our trig functions. So the sides that we're talking about are adjacent, opposite, and hypotenuse. So the hypotenuse is always the easiest to identify because it's going to be the longest side and it's always across from the right angle. So I have two pictures here, and in both pictures, our side across from our right angle, so remember this little box here means right angle, so this is going to be the hypotenuse on both of these. And then when we're talking about the adjacent side and the opposite side, it is always in terms of which angle we are talking about. So on this picture, here's my theta, so I'm referencing this angle here. So the opposite is always going to be the side across from the angle that we are talking about. So this is going to be our opposite side. And then the adjacent side is next to our angle that's not the hypotenuse. So this will be the adjacent side. Now, if I switch the angle that I'm talking about, so now if I'm talking about this angle up here, the side across is going to be down here. So this is the opposite. And then the side next to my angle that's not the hypotenuse is the adjacent side. Okay. So again, when we are talking about opposite adjacent, it always is in reference to an angle, so the non-right angle. Okay. So now that we know how to do that, we can start talking about our trig functions. So there are 6 of them. And we should have learned sine, cosine, and tangent last year in geometry. And to help us remember the ratios, we use the acronym Sohcahtoa. Sohcahtoa. Okay. So to remember how to use this, this means sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay, so those are each of the ratios. And then sine, cosine, and tangent also have an abbreviation when we write them. So when I'm talking about sine, I write it as sin, and then we typically use our theta symbol. And again, it's going to be equal to the opposite side over the hypotenuse. Cosine is abbreviated as cos. And then again, theta represents the angle. And then our ratio is adjacent over hypotenuse. And tangent is abbreviated as tan, and then our theta to represent our angle. And then this is the opposite side over the adjacent side. Now we're going to add 3 more trig functions. So these are usually referred to as the reciprocal functions. So I'm just going to make a note of that. So reciprocal. So what it means is that if I'm talking about the cosecant, this is really the same thing as 1 over sine. So the cosecant is a reciprocal to sine. And its abbreviation is going to be CSC, and then our theta. Okay. So again, we are thinking of this as either 1 over sine, or it would be the reciprocal of this. So this is going to be the hypotenuse over opposite. And then secant is a reciprocal to cosine, abbreviated as SEC. And then our theta. So again, we're thinking of it as 1 over cosine, or as a reciprocal to cosine. So again, this will be the hypotenuse over the adjacent side. Okay. And then the abbreviation for cotangent is COT. Okay. And this is the reciprocal to tangent, so 1 over tangent. Or we would think of it as adjacent over opposite. Now with tangent, that one is also special because we can think of tangent and cotangent, since they're reciprocals, in terms of sine and cosine. So we also need to know, use a different color, that tangent is equal to sine theta over cosine theta. Okay, so that's another way to think of tangent, which means that the cotangent would be equal to cosine theta over sine theta. Now it's going to be more important to know that in our next chapter, but that is another definition of tangent and cotangent. Okay. Now when we are finding lengths of sides, or if we're asked to write ratios, we are going to be using these functions. Okay. So again, these are going to be to find lengths. So maybe make a note of that off to the side. So use to find lengths. Now to find angles, we are going to use the inverse functions. Okay. So use to find angles. Okay. So the way we write the function is just going to be a little bit different. So we talked about inverse functions in the past, so we represent them with that -1 exponent. So if we're talking about the inverse of sine, we would do sine and then -1, and then instead of theta, we would actually put the ratio in there. So we would use the opposite over the hypotenuse, and then that's going to be equal to theta. And then for the cosine, so again, cosine, and then the little -1 represents inverse. So we would say this as inverse cosine. And we would use adjacent over the hypotenuse when we solve this. And then that will give us our angle. Okay. And then the last inverse one is going to be the inverse of tangent. So this will be opposite over adjacent. Now, if you're looking at your calculator, whether you have a graphing calculator or just a basic scientific one, you should see sine, cosine, and tangent. So I'm just going to grab my graphing calculator real quick just to kind of show you. So on mine, I have sine, cosine, and tangent. So if we are going to be using our calculators to help us solve, we always have to put our things in terms of either sine, cosine, or tangent. So we're not going to see these reciprocal functions on there. So it's important to know that the cosecant is reciprocal to sine, so we would have to use this fraction to help us solve. Same thing, cosecant is the reciprocal to cosine, cotangent is the reciprocal to tangent. And then anytime we are finding an angle, we use the inverse. So if you have a graphing calculator, you'll notice above the sine, cosine, and tangent keys that we have the inverse keys up there. So we would use those if we were finding angles. And we will do some examples in the next set of videos so you know how to use those.